Welcome back after the break, and let's continue with our next question in our question paper, and that's question 1.5. Study the figure 1.5 that shows us drainage basins. Now immediately when I look at the diagram, I see two drainage basins. If you look at the first one, you can see it's a dendritic pattern. It looks like it resembles the branches of a tree. Then we have another one, it's also dendritic but much smaller. So I can definitely see that drainage basin A has got a high density and this got a lower density. What separates one drainage basin from another area is the watershed. Now let's quickly go and have a look at the questions that's being asked regarding this drainage basin. Define the term drainage basin. It's an area drained by a river and its tributaries. Now tributaries is the other rivers joining the main river. Let's just quickly go back here. As you can see, this river got many tributaries. There's one over there. Other rivers joining the main river. Now very importantly, what separates one tributary from another one is the high-lying area. It's known as the interfluve. Don't forget that. That might be questions coming up. Now let's continue looking at our next question. Does drainage basin A, north of the watershed, or drainage basin B, south of the watershed, has a higher drainage density? Now I've just mentioned that to you before. Obviously, if you look at drainage basin A, much higher drainage density because you see more surface runoff. You see more tributaries than comparison to drainage basin number B. So the correct answer over there will be A. So the correct answer is A. Now state one factor that could have contributed to the high drainage density of the drainage basin identified in question 1.5 and 2. And I'm going to give you quite a few. First of all, the amount of vegetation. So we can say that A has less vegetation because if there's vegetation, what's the water going to do? It's rather going to infiltrate and we're going to experience a lower density. So there's vegetation cover, and we can say the steepness of the gradient. Drainage basin A might be on a very steep gradient, so what happens? The water don't have time to infiltrate. If it was on a flat gradient, the water will be allowed to infiltrate, and there will be a low density. So I'm just going to write there relief and the gradient, and then the permeability of the rock. We did explain in the previous lessons, permeable, it allows water to infiltrate. Impermeable doesn't allow water to infiltrate. So the chances are that drainage basin A is impermeable because it doesn't allow water to infiltrate. So I'm just going to write there permeable rock. It can be impermeable or permeable. Okay, and lastly, the amount of precipitation, the amount of rainfall. So it can happen that if you look at drainage basin A, receives more rainfall than drainage basin B, and obviously it will lead to more surface runoff and tributaries that's forming. Determine the stream order at Z in drainage basin B. Now if we quickly have a look at drainage basin B, so we need to determine the stream order. And I've seen they've done the stream order over there, so definitely there's a first stream order. But let's just quickly do this together. There's a 1 and there's another 1 stream order. A 1 and a 1 makes a 2. So there's a 1 and there's a 1 and that makes a 2. A 2 and a 2 makes a third stream order. So Z will be a third stream order. And that will be your correct answer. Refer to drainage basin A and state the relationship between stream order and the A, length of streams, and if you look at B, the number of streams. Now this is quite if we quickly have a look at it, now the length of streams, the lower the order, the shorter the streams. And when we see the number of streams, the lower the order, the more the number of streams. The more number of streams in that order. So basically what they tell us, if you look at drainage basin A, I'm going to show you over here, as you can see, if there's more streams, there's going to be more low order streams. And if our more high order streams, like for instance third order streams, how longer the length of the streams are going to be. Evaluate the effect of a prolonged period of drought on the stream order at point Y in drainage basin A. Now let's quickly just have a look at stream order Y. Situated over there. Now imagine we experienced a drought. What will it have effect on the stream order at Y? Obviously, first of all, it will change the stream order to a lower value. It will not be a 3 anymore. So that will be your correct answer. And the correct answer, it will change the stream order the stream at Y to a lower order. Okay, now if you look at our next questions, refer to figure 3 1.6 showing river grading on a longitudinal profile. Now as you can see, I'm just going to look at it. All river starts from a source till the mouth. As you can see, there's a couple of nick points. Now nick points is basically temporary base level of erosion that takes place. Now over here on number B, sketch B, there's a beautiful longitudinal profile. You can see the shape of it. It's concave in shape. There's a lake, that's a nick point. If you look at the information given to us, there's a drop in sea level, definitely. If you look at the sea level, it drops over here in source A. At B, waterfall erosion will exceed deposition, so there's a lake that exists because of that. And there you see source, beautiful longitudinal profile, a concave profile with only permanent base level of erosion. So let's quickly go and have a look at the questions as being asked. Give a geographical term to describe the irregular shape of a longitudinal profile B. And that, if you look at number B, you can see there's quite a few nick points. It's not concave in shape, so we say it's an ungraded profile. Now, name a temporary base level evident in profile number B. Let's have a look over there. There's quite a few. I mean, over there's a waterfall and there's a lake and rock outcrops as well, such as here. So we just mentioned what we can see. We can see a waterfall and we can see a lake. So that will be the correct answer. Okay, what evidence suggests that rejuvenation has taken place in longitudinal profile A? Now, rejuvenation means a river gains more energy. Now, the reason for rejuvenation taking place over there, because you can see there was a drop in sea level, original sea level that took place, and there's presence of nick points. So that's our two correct answers. Okay. A drop in sea level and nick points is present. And we can also say that it's because it become an ungraded profile. Describe with reasons the changes a river meander will undergo with after rejuvenation. So what will happen when the river gains more energy? Basically, it will become incised meanders, will develop. The meanders will have steeper sides. And lastly, will form a cut-off meander or oxbow lake. Okay, now the reason was, if you quickly look at the next question, 1.6.5, in a paragraph for approximately 8 lines, explain the process that assisted the graded profile in C to have a steep gradient in the upper course and a gradual gradient in the lower course. Now the reason for it, if we look at C, that we're going to have a look at, as you can see where the middle course is, that's where the middle course is, that's where the middle course is, and that's where the lower course is. So this is the upper, middle, and lower. And the reasons for the process creating the steep gradient in the upper course is the following. Because of headward erosion. Okay, I'm just going to write here, why is it so steep in the upper course? Because of headward erosion being experienced. Because of downward erosion happening in the river beds. Taking place over there. And we can also say because of the water that flows turbulent. Now, if we look at the question, the reason why it's such a gradual process, gradual gradient in the lower course, why is it so beautifully concave and slope? Because of lateral erosion taking place, because of deposition of sediments, and we can mention because of the laminar flow of water taking place. Laminar flow of water taking place. Okay. Now, grade 12, that was question 1. Unfortunately, we ran out of time for today's lesson, but please stay tuned for the next lesson where we're going to discuss question number 2. I hope you enjoyed the question, and I hope you've learned something. See you next time around.